So continuing off the previous video, let's take a look at finding LRAM, RRAM, TRAM, and MRAM while now using a table instead of a graph. So remember in the previous video that the way we calculated rectangles in the graphs was by taking delta x, which is our change in x or the length of our base, multiplied by the y value or f of x. And with tables it's the same exact way, same exact process, it's just shown, the data is shown in a different way. So let's just start by finding out what RRAM or LRAM is equal to. So once again, LRAM is your left Riemann sum, so we have to start from the leftmost endpoint of x equals 0 and work our way to the right. So our delta x is just going to be the distance from one x value to the next. So from 0 to 4, that is our delta x. And so our delta x is going to be 4, because 4 minus 0 is just 4. And then times our f of x, and since we're doing LRAM, we're just going to take the left y value. So it's the y value is negative 3, so we put 4 times negative 3. Now plus our second or next rectangle. So we went from 0 to 4, now we're going to go from 4 to 9. So our delta x is 9 minus 4, which is 5. That's the distance between the x value of 4 and 9, times the next y value, which is negative 5. And we're just going to repeat this process until we get to the end. So now from 9 to 10, our delta x is just 1, and our y value is negative 4. From 10 to 12, the delta x is going to be 2, times the y value of negative 2, plus the next delta x, so 12 to 19, that's going to be 7, times the value with the y value of negative 1, and then plus, we're going from 19 to 21, so that's a delta x of 2 times the y value of 1. And that's where we can stop. Since we're doing LRAM, we're not going to include the final y value, and when we do RRAM, we're not going to include the leftmost y value, since we're starting from the rightmost endpoint and going to the left. So when you add this up, you should get an area of negative 50 units squared. So now, as mentioned before, with RRAM, or when you calculate RRAM, you're going to start from the rightmost endpoint, so at the x value of 21, and we're going to include the rightmost y value, and then we're going to work our way left. So starting with the rightmost x value of 21, when we go from 21 to 19, the delta x is still going to be 2, because the distance we travel is just 2 to go from 21 to 19, or from 19 to 21. So we do 2 times the rightmost y value, which is 2, plus, we're going from 19 to 12, so that's 7, times the y value of 1, plus, from 12 to 10 it's 2, times the y value of negative 1, plus 1 times the y value of negative 2, plus from 9 to 4 it's 5, so 5 times negative 4, and then plus from 4 to 0 it's 4, and we get the y value of negative 5. And notice how in LRAM we didn't include the last or the rightmost y value, so in RRAM we won't include the leftmost y value. And when you add them all up, you should get negative 33. So now if we were asked to find TRAM, or trapezoidal RAM, once again the formula for trapezoidal RAM is just the average of the LRAM and RRAM. So we can just take your LRAM, which is negative 50, plus the RRAM, which is negative 33, over 2, and that will give you negative 41.5. So now let's say we're going to find MRAM, or your midpoint RAM. So in order to calculate MRAM, you need to make sure there are an odd number of x values. So here there are 7 different x values, because what you have to do in MRAM is you start from the leftmost endpoint and just skip over one and go to the next one. And what that will do is leave you with a midpoint value here, or specifically the midpoint y value, because that is what we're going to include when we calculate our MRAM. So our delta x is actually going to be the distance that we skipped over. So we're going from 0 to 9, so our delta x is going to be 9. And from here we go from 9 to 12, so our delta x is 3. And then on the last section we're going from 12 to 21, so our delta x is actually going to be 9. So once again, we're still doing delta x times your y value, or f of x. So for this time, for LRAM, we're going to take the first delta x, which is from 0 to 9, so delta x is going to be 9, times our midpoint y value. So this is the midpoint between these two sections, or between those two x values. So our midpoint y value is -5. Plus our next delta x, so we're going from 9 to 12, so our delta x is 3, times our midpoint y value, and that specifically is -2. Now plus our final delta x, so from 12 to 21, that's a delta x of 9, times our midpoint y value between the sections that we skipped, and we get 1. So when you calculate it, it should get you a total of -42 units squared.